Let's get into it. Number 10. Extreme density. You scoop a teaspoon and it feels like a mountain falling through your hand. That is not a metaphor. The average mass packed into a single spoonful of this material would outweigh anything you can pick up on Earth. This is the result of a dead star. A sun runs out of fuel and gravity instantly wins. The core collapses inward at a quarter of the speed of light. The iron core is crushed so violently that electrons are forced into protons. They vanish. They turn to neutrons. A sphere millions of miles across becomes a ball the size of a small city. You're looking at a city-sized sphere holding the weight of an entire solar system. The material inside is called neutron fluid. It is a perfect superfluid with zero friction. If you stirred a cup of this fluid, it would spin forever. And this is not just heavy rock. It's a terrifying new state of reality. The surface is a solid crust of iron isotopes that is billions of times stiffer than steel. When gas from a companion star falls onto it, the gas does not just glow. It detonates upon hitting the solid crust. Black holes are just empty voids. This is a solid wall that fights back. Anything that hits the surface releases energy like a nuclear bomb. The star slams infalling material into a solid skin and converts kinetic energy into heat and light with terrifying efficiency. Scientists picture these objects as giant atomic nuclei. That idea is not poetic, it is pure physics. This dense packing turns ordinary cosmic dust collisions into violent explosions. The star literally screams when it eats. That scream's the real threat, and it keeps getting louder. Number 9. The strongest material in the universe. If you cross the event horizon of a black hole, you find nothing but empty and severely warped space. A neutron star is a physical object. Deep inside its crust hides the strongest material in existence. Under the crushing pressure of extreme gravity, atomic nuclei are squeezed so tightly they lose their normal shapes. They merge into bizarre and ultra-dense structures. Scientists call this material nuclear pasta. Moving deeper into the crust, you find shapes resembling gnocchi. Go deeper and you find long strands like spaghetti. Further down you find flat sheets like lasagna. This whimsical name hides a truly terrifying reality. Nuclear pasta is roughly 10 billion times stronger than steel. It is a physical structure pushed to the breaking point of material science, where it takes the weight of a mountain just to form a microscopic millimeter of it. The star is spinning fast and the crust is under unimaginable tension. When that tension overcomes the pasta, the star suffers a starquake. The pasta cracks. The release of energy is so violent that it shakes the fabric of space-time. It sends a burst of gamma rays across the galaxy. A black hole cannot crack because it has no structure. The neutron star is a physical bomb, and the pasta is the trigger. It is an indestructible cosmic architecture that defies human comprehension. Number 8. Trillion Tesla magnetic fields. The Earth has a magnetic field of about half a Gauss. A standard fridge magnet is about 50 Gauss. Certain neutron stars are called magnetars. They have a magnetic field of a quadrillion Gauss. If you floated halfway to the moon, a magnetar sitting where the Earth is would rip the iron straight out of your blood. It would distort the water molecules in your body until you dissolved. The magnetic field is so dense that it actually has physical weight. It creates a drag on the crust. The magnetic field lines tangle like twisted rubber bands. The tension builds for decades. Then it snaps. The snap releases a magnetic flare that can blind satellites on Earth from halfway across the Milky Way. In the year 2004, a magnetar flare hit our atmosphere. It ionized our upper atmosphere from 50,000 light-years away. Black holes have magnetic fields, but they do not have a solid crust to anchor them. The magnetar is an anchored cannon. Electrons are locked into long, narrow pipes along the field lines. This changes chemistry and radiation. Now, the magnetic field does mechanical work on the crust. When it snaps, we see a gamma-ray wall of fire. The star is not quiet. It is primed and ready to fire. Number 7. Millisecond spins. Think about an ice skater pulling her arms in to spin faster. Now imagine an object twice as heavy as the sun shrinking to the size of a city. Conservation of angular momentum forces it to spin at mind-bending speeds. The fastest known neutron star spins 716 times every single second. At its equator, the solid surface is traveling at 24% of the speed of light. This creates a mechanical nightmare. The intense spin whips the magnetic field around and creates a pulsar wind. It blasts out beams of radiation from the magnetic poles. As the star spins, these beams sweep across the galaxy like a lighthouse. We hear them on Earth as a precise ticking. The ticking is so accurate it rivals atomic clocks, but it is not a peaceful ticking. It is a sign of immense kinetic energy. If the crust shifts by a fraction of a millimeter, the spin suddenly changes. Scientists call this a glitch. The glitch dumps terrible amounts of energy into the surrounding space. The surface is moving at a good fraction of the speed of light. That motion tears matter and rips magnetic footprints across space. Black holes can spin too. You never get a solid spinning surface slamming plasma into a beam like this. The star becomes a living machine whose spins can suddenly misbehave. Number 6. Starquakes and giant flares. We have earthquakes on our planet. They move tectonic plates by a few inches and cause widespread destruction. A starquake on a neutron star moves the crust by a millimeter. Because the gravity is 100 billion times stronger, that millimeter movement releases more energy than our sun will produce in 100,000 years. The crust is a rigid lattice of atomic nuclei. It does not want to bend. It only breaks. When the magnetic field shifts, it pulls on the crust. The crust fights back until it shatters. The resulting seismic waves travel through the star liquid core. The surface shakes. The magnetic field violently realigns. This flings a shock wave of charged particles outward at near light speed. The outer shell in these objects is solid in a way that surprises people. The crust behaves like a brittle crystal held under colossal stress. Over years, that stress builds until it snaps. Our evidence shows flares that set instruments off across the galaxy. Starquakes can launch charged particles at near light speed. This is not a local problem. The shock wave can ionize gas far away and create pulses detectable across many wavelengths. The safety comparison with black holes again flips. A black hole swallows silently. This star breaks and screams. Its screams leave fingerprints that scientists can read for decades. Number 5. Kilonova and element factories. What happens when two of these extreme machines find each other? They lock into a binary orbit. Over millions of years, they radiate energy as gravitational waves and slowly spiral together. In the final moments, they are orbiting each other hundreds of times a second. Then they collide. The impact shatters the crusts and spills the ultra-dense core material into open space. Without the crushing gravity to hold it together, the neutron fluid violently expands. The free neutrons are captured by surrounding atoms in fractions of a second. This is called the rapid neutron capture process. It forges the heaviest elements in the universe. Gold, platinum, uranium. A single collision creates Jupiter weights of solid gold. The resulting explosion is called a kilonova. It is accompanied by a short gamma ray burst. This blast is a narrow beam of pure destruction. If that beam points at a planet, it wipes out the ozone layer and sterilizes the surface in seconds. The violent mixing and rapid nuclear reactions make an explosion brighter and more complex than a single supernova. Her black hole mergers do not produce this kind of chemical factory because they swallow most material cleanly. These stars give, and what they give includes the atoms that later build planets and life. When two collide, they can make a flash that damages atmospheres. Thankfully, these events are rare, but their physics is awe-inspiring and deadly. Number 4. Tidal crushing and ripping. Spaghettification is famously associated with black holes. Neutron stars do it too, and they do it while you can still be seen. If you fall toward a neutron star, the gravity at your feet is vastly stronger than the gravity at your head. This tidal force stretches you into a long, thin string of atoms long before you hit the surface. Now apply this to an entire star. If a normal star wanders too close to a neutron star, the tidal forces grab it. The normal star is stretched into a teardrop shape. Gas is violently ripped from its surface and pulled into a swirling accretion disk. The neutron star literally eats its companion alive. As the gas spirals inward, friction heats it to millions of degrees. It glows brilliantly in X-rays. The less dense star is shredded into a spiral arm of hot debris. Black holes do this quietly behind an event horizon. The neutron star forces the destruction to play out in brilliant and blazing light across the sky. Simulations show that just before a black hole swallows a neutron star, the surface can crack, and the magnetic field violently reconfigure. That means when tides meet magnetic stress, the result is a multi-stage catastrophe. Black holes do tidal work too, and the presence of a hard surface and extreme fields makes the ripping process louder and messier. The shredded matter lights up instead of silently disappearing. Number 3. Exotic cores and quark matter. The crust is iron. The mantle is nuclear pasta. What is at the exact center? The pressure at the core is so extreme that even neutrons cannot survive. The boundaries between individual neutrons break down. They dissolve into their fundamental building blocks called quarks. This creates a core of strange quark matter, a frictionless and super-dense soup of up quarks, down quarks, and strange quarks. This is a state of matter that has not existed freely since the first microsecond of the Big Bang. Here's the terrifying part. If a neutron star gains a little extra weight, the pressure in the core increases. Or the normal neutron matter might suddenly undergo a phase transition into quark matter. Or this happens in a fraction of a millisecond. The core shrinks instantly. The rest of the star collapses inward and bounces off the new quark core. This triggers a second explosion called a quark nova. The star violently ejects its outer layers while the core converts entirely to quarks. Some theories even predict a quark nova, where a neutron star converts and releases a pulse more energetic than standard supernovae. This is theoretical, but serious. It means these objects can abruptly change their nature and send energy out in strange forms. Black holes are final. These stars hold a hidden internal bomb that can rewrite the laws of physics at any moment. Number 2. Black widow pulsars. Black holes are famous for quietly swallowing stars that wander too close. Some neutron stars prefer a much more violent execution. They are predatory. We call them black widow pulsars. They are rapidly spinning neutron stars trapped in a close orbit with a smaller companion star. The pulsar spins incredibly fast, generating a ferocious storm of high-energy radiation and a wind of antimatter particles. This wind does not just pull gas off the companion, it actively blasts the companion star. The radiation strikes the facing side of the companion, heating it to the point where the star begins to evaporate. Instead of just pulling gas into an accretion disk, the Black Widow unleashes a blazing storm. This relentless death beam boils the companion star alive. It vaporizes its partner layer by layer, blasting the stripped material out into deep space until nothing remains. Over millions of years, the Black Widow consumes and vaporizes its partner. It uses the companion orbital energy to spin itself up, and then destroys the very star that fed it. While a black hole consumes its prey relatively cleanly, a Black Widow actively burns its partner to ash using a focused cosmic blowtorch. It is a slow and agonizing stellar destruction that makes the silent feeding of a black hole look almost merciful. Number 1. Gravitational wave fireworks and observable danger. When black holes collide, they send out gravitational waves. They warp space and time, but they do it in total darkness. Unless they are surrounded by gas, you will not see a flash of light. Neutron stars are entirely different. When they merge, they are loud in every possible way. They shake the fabric of reality, sending out gravitational waves that we can detect on Earth. They also put on a terrifying fireworks display. The collision launches a jet of radiation that cuts through space at the speed of light. It blows out a kilonova that glows 1 billion times brighter than the sun. It showers the surrounding light years with highly radioactive heavy elements. Telescopes across the entire electromagnetic spectrum can see the blast, from radio waves to visible light to X-rays and gamma rays. They do not hide their violence. They broadcast it to the entire universe. The observational payoff is incredible. The terrifying payoff is that the most destructive signatures are visible far away and can have directional jets that deliver lethal radiation. And black hole mergers produce waves too, but often lack the bright electromagnetic counterpart that makes the event both visible and chemically active. They are the ultimate cosmic engines of creation and destruction. They prove that you do not need an event horizon to be the most terrifying object in the dark. Neutron stars are not weaker cousins of black holes. They are different machines of extreme physics. They crash and explode and crack and light up the universe in ways that make a silent horizon look tame. If one passed near our neighborhood, the immediate danger is its radiation and magnetic fury, not an invisible swallowing. Which of these 10 makes you sleep worse tonight? Tell us in the comments which one you would rather face and why. Alright, if one of these shocked you, share the video with someone who still thinks black holes are the only scary thing in space. Like if you learned something, and subscribe for more short shocks from the universe.